there again. So this is Tierney again, coming from Monroe Community College, and this is the second part of our atomic mass video series. This is atomic mass 2. So the last video we went over some basic atomic mass calculations involving finding the average atomic mass, and now we're going to get into some more complicated variations of those calculations. So if you recall, the average atomic mass was calculated by finding a weighted average of each atomic mass, taking into consideration its fractional abundance. Recall that the fractional abundance is found by taking our percentage and dividing it by 100. So let's look at one of these more complicated problems. So problem example 6 is what we're going to do next. Let me read it for you. A hypothetical element X has two stable isotopes. X46 has a mass of 46.046 AMUs. Yes, I got very creative with those numbers. And X51 has a mass of 50.826 AMUs. Calculate the natural abundance of X46. The average atomic mass of element X is 47.763 AMUs. So what you should do right now is, if you have a good start, if you think that you know what to do, I want you to pause this video and just continue calculating. If you really have no idea, well, I would like you to give it a try. Okay, start the problem. See how far you can get. If you get stuck, what I want you to do is press play and watch me do the first step, and then see if you can take it from there. Okay? So either pause the video now and do the entire problem, or pause the video when I have done the first step. I'm going to give you the answer for those of you who think that you can do it. So pause the video now. Did you pause it? If you did the entire problem, the answer is 64.08%. If you have no clue how I did that, that's okay. This is a pretty complicated algebra problem, so what I'm going to do is go through the problem steps for you so that maybe you can do a problem like this on your own next time. So, what we know is the average atomic mass is 47.763 AMU. That is what we calculated last time. So that is our average, so 47.763 AMU. And that is going to equal, and there are two stable isotopes, so we're going to have two terms. Now, X46, we know the isotopic mass, but we don't know the fractional abundance. So the fractional abundance of this, we're going to call X. Okay? So we're going to say X is our fractional abundance, and we're going to multiply it by its isotopic mass, which is 46.046 AMU. We're going to add that to the term for the second isotope, which is X51. That fractional abundance we're going to call Y, because we don't know that either. But we do know its isotopic mass, which is 50.826 AMU. Now, if you think that you've got it, if you didn't do it before, try it now by pausing the video and giving it a whirl. If you're still stuck, let me help you with this next step. So, we know that if there's only two stable isotopes, their percentages need to add up to 100%. So, if we are talking about fractional abundances, the fractional abundance of 100%, if we divide that by 100, it's equal to 1. So, our fractional abundances are adding up to 1. And now we have two unknowns, but we have two equations, so we can solve for it. So if you were stuck before and you think you might be able to do it, try it now. So let me continue on with this explanation. What we want to do is we are looking for this right here. We are asked for the natural abundance of X46, but we can get the percent abundance from the fractional abundance. So this number right here is what we're looking for, X. So we need to plug something in for Y to make it in terms of X. So we're going to solve this equation right now for X. So Y is equal to 1 minus X. Since we know that this is equal to Y, we can go ahead and plug that in for Y. What I'm going to do right now is, we know that all of our units are going to work out because of the way that this is set up. We should end up with something without a unit. So I'm going to shorten things up and not write the units. Oh, whoops. 47,763, sorry about that, is equal to 46.046x. This is the same as this term, I just put the x at the end because that's how we're used to looking at it in terms of algebra. We're going to have 1 minus x in for y, and we're going to multiply that by 50.826. So now we're going to FOIL this last term, multiply it out. So we have 47.763 is equal to 46.046x plus. So 1 times the 50.826 is 50.826 minus x times 50.826, which would be 50.826x. So now we need to get all of our like terms. Oh, whoops, look at that. I missed an x there. Sorry about that. So that x is just going to go down there. So our like terms, our x terms, are both on the right side. This one and this one. This 50.826 we're going to carry over to this side by subtracting. So we're going to get 47.763 minus 50.826 is equal to 40, whoops, sorry about that, sometimes that happens. I think it did in the last video. 46.046x minus 50.826x. So now I seem to have run out of room, so I'm going to continue on to the next screen. 47.763 minus 50.826 is equal to, let's do that one together, negative 3.063. So I'm going to, whoops, negative 3.063. And does that have an x on it? No, it doesn't. That is equal to, now let's go back, 46.046x minus 50.826x, that is equal to negative 4.78. Notice, when you put it in your calculator, it says negative 4.78. However, both of these guys have 3 digits after the decimal, so we need to have 3 digits after our decimal according to significant figures for subtraction. So this is negative 4.780x. So we're going to divide both sides by negative 4.780. And x is going to be equal to, when these guys cancel out, 0.64. It looks like we need 4 significant digits. That, when we multiply it by 100, is equal to 64.08%. So the key to doing these problems is making both equations and then substituting in to the other equation. What I would like you to do is give a try to the next problem. It's the now it's your turn problem. So the now it's your turn problem means that this is a very similar problem to the one that we just did. I just don't show you how to do it. And so what I want you to do is work as far as you can into it, see if you can get an answer, and then when we get to class, you're going to compare it with a classmate or two and see how you guys did, and then if necessary, I can work that problem out for you. However, I am going to be looking around to see who did the problem, and it's going to be worth a grade. So you're definitely going to want to give this as much of a try as you possibly can. Good luck, and I will see you in class.